Hi friends, good evening everyone. This is Manjunath Sir, CSAT faculty in IASBABA. Friends, in this video we will solve the remaining problems of CSAT 2023, and you may be knowing it was one of the toughest question papers so far. Let's see the remaining ones from the same question paper. Here is the very first one, and I am doing B series, and this is sixth problem in B series. A box contains 14 black balls, 20 blue balls, 26 green balls, 28 yellow balls, 38 red balls, and 54 white balls. Consider the following statements. The smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color is 175. The smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color. At least one ball of each color is 167. Here it is one full group of at least one color is 175. And your options are 1 only is correct, 2 only is correct, both are correct, neither is correct. Here first pick up the greatest figures, greatest numbers. 54 is the greatest. Those many we have got white. 38 red, 28 yellow, 20 blue, 14 black. Okay, so this is in the descending order. 1 2 3 4 5 6. 1 2 3 4 5 6. So 26 are green in between. 26 are green, 20 blue, and then 14 black, and that is the least. Let us forget it. Just add all these numbers, how much you will get? 4 plus 6, 10. Here is 16. 10 plus 16, 26. 26, 2, 4, 6, 8 plus 8, 16. So except the last 14 black, we have 166 balls, right? And if you pick at least one more, then you will have black colored balls also. Meaning this is the least. This is the least which you will have to pick, so that you must have at least one ball of each color. Okay, so the trick is, first we will have to add all the greatest numbers, plus 1 gets you the answer. So here is that 167, therefore 2 only is the correct answer. Okay, 2 only is the correct answer. 175 has nothing to do with this. Okay, because even if you add any numbers, and here he has given one full group of at least one color. One full group of at least one color he is saying. Therefore 175, that is ruled out. 167 is 100% correct. Therefore 2 only will be the final answer, right? Now I will give you one simple example how this works out. Okay, 167. Assuming there are 14 white, 18 blue, and say 12 are green colored balls in a bag. Okay, now I want a ball of each color. So what is the minimum number of balls I must pick? I want at least one of each color. In this case, what we must do is pick up the greatest. These are the greatest. 18 plus 14 is 32. 18 plus 14 is 32. If you take out 32, you may end up getting all white and all blue, but there is no scope of getting green. You may get, but are you sure? No. But if you pick 33, then you will be surely having at least one ball of all the colors. Okay. Same thing is here in the second. We want at least one of all the colors. So in this case, what we must do is pick up the greatest figures plus 1 gives us the final answer, right? Now moving on to the next one. Consider the following statements. A is older than B, C and D are of same age, E is the youngest, F is younger than D, F is older than A. How many statements given above are required to determine the oldest person or persons? Okay, fine. So how many you want to pick the oldest, right? So here let us follow this line. What is this? On this side youngest, on that side eldest. Okay, it is in the ascending order, younger to elder. Okay, A is older than B. A will come on this side, B on this side. A is older than B, and we want oldest. So B is ruled out, and we want this information to get the oldest. We want this information, obviously, right? Because A is more preferable than B. Here B is straight away ruled out, right? So we want this. C and D are of the same age. C and D are of the same age. Where exactly they come, we don't know. C and D, they are of same age. Okay. Where exactly they will fit, we don't know. They can come in the beginning, they can come in between, they can come on this side also. Okay. E is the youngest. E is the youngest. He is in the end. He is in the end. Youngest. Meaning he is ruled out because he is not the eldest. So this also, this information also we want. Next, F is younger than D. Here is D. F is younger than D means it is like this. D on this side, F on that side. So D is more preferable. D is more preferred than F because D is elder. Okay. So F is ruled out. See here, F is ruled out, B is ruled out, E is ruled out. They cannot become the oldest. And next, F is older than A. A is here. F is older than A. Meaning, we used all the informations to find the oldest, right? So C and D can fit here, or here also no problem, but definitely not here. Okay. So C and D are of same age, and F is younger than D. If F comes here, then C and D will come here. Okay. Otherwise F here, C and D here. But F is older than A. So F on this side, right? F is older than A. So A, of course, this is clear. And F is younger than D. So younger than D means D will, F is younger than D, D will go here. So D here, meaning C and D are of same age, right? So now let me draw it again. E is the youngest, E will come on this end. C and D are of same age. C and D are of same age. F is younger than D. Here is D. Here who will come? F. F is younger than D. E is the youngest. Yes. C and D are of same age. Yes. A is older than B. A is older than B. A will come on this side. B on this side. Why they will come in between? Because there is a relationship between A and F. See here. F is older than A. So we used all the informations, and to find out the oldest, we used all the informations. Therefore, the final answer is the last option, all the 5, right? So this is everything about this problem. Moving on to the next one. Consider the following, including the question and the statements. There are 5 members, A, B, C, D and E in a family. We have got 5 members in the family. Statement 1, A and B are a married couple. A and B are a married couple. D is the father of C. E is D's son. A and C are sisters. These are the informations. And which one of the following is correct in respect of the above question and statements? What is the relationship between relation of E to B? How E is related to B? That is the question. See here, for male we use box, for females we use circle, single line, same generation, double line, it is couples, for couples, because couples also they will be of same age, okay. And children down, parents up, right? These are the information, these are the things that we can use while solving problems on blood relations, right? So A and B are a married couple. You can write it like this: A and B are married couple. We don't know who is male, who is female, okay. So that's it for the first statement. D is the father of C. D is the father of C. This is how you can write. D is father. Father means male. Children down. D is the father of C. E is D's son. E is D's son. This is also clear. A and C are sisters. Now he will connect. Here A and C are sisters. Okay. A and B are married couple, that is clear. D is the father of C. D is the father of C, that is also over. E is D's son. E is of course D's son. A and C are sisters. Here he is connecting A and C are sisters, meaning she is female. Single line, she is also female. Now you will have to take all these things here. D will come here and E will come on this side. Now you can cross verify everything. A and B are married couple. Male, husband, wife, married couple. D is the father of C. D is of course father of this C. E is D's son. E is of course D's son. Yes, that is also correct. A and C are sisters. A and C are sisters. Meaning A has got these 3 children. A and C are daughters of D. E is the son of D. And A is married to B. B is husband, A is wife, right? Now the question mark is on how E is related to B. This E, how this E is related to B. B has got a wife and wife's brother. Wife's brother is brother-in-law. Wife's brother is brother-in-law. we could answer this question only when all the informations are used. Okay, first we must know these two are husband and wife, and we must also know the relation between A and E. For that, you will have to have all the informations. Therefore, the answer is all the four statements together are sufficient to answer the question, right? It is not like you could not answer this, okay, using all these informations. You can answer the question asked, but you are supposed to use all the informations, because only then you can establish the relationship between B and A, right? B and E, right? So the third option should be marked. We require all the things, all the informations. So the third option, C, should be marked. Moving on to the next one. Consider the following in respect of prime number P and composite number C. See here, this is one more problem on related to prime numbers. Okay, and in my earlier videos also I had talked about this. Prime numbers are very, very crucial, and almost a similar type one problem was asked, I think in the year 2021 or 2020. Okay, you can check it out. So there also it is same, and there he has given P and Q. One is prime, the other is composite, and almost on the similar lines he has framed the question again, right? So this was on the expected lines, not a surprise, right? Now P should become a prime number and C a composite number. We know prime numbers are 2, 3, 5, 7, 11, all these are unbreakable numbers. Composite numbers you can take 15, 17, 15, then 18, right, 10, this kind of numbers you can take for C. Now coming to the questions, I mean the statements, which of the statements given above are correct? 1 and 2 only, 2 and 3 only, 1 and 3 only, 1, 2 and 3, right? So first statement says P plus C divided by P minus C can be even number. 17 plus 15, 17 minus 15. See here, he has used the word can be. Can be means you are free to take any numbers. Okay, not necessarily always, that's the meaning, not necessarily always. Okay, can be means they can be, it can be even number. Now P is prime, C is composite. Of course 17 is prime and 15 is of course a composite number. 5 3s are 15, composite number. 17 is unbreakable number, prime number. So P plus C, P minus C. If you add these two, you will get 32. If you subtract, you will get 2. 2 1s are 2, 16s are 16 is of course an even number. 16 is of course an even number. So everything is all right with the statement number 1. So P plus C divided by P minus C can be even, confirmed. Now let us check the second one. In the second one, what I will do here is I will take P's value 2, C value 15. Can I do that? You can do, but check whether it can be an odd number or not. Okay, can it be an odd number? 2P plus C, 2 into P, 2 into 2 plus C, C is composite number 15. 2 2s are 4 plus 15 is 19. Is it odd? Yes, of course it is an odd number. So 2P plus C can be an odd. This is also correct. Now I will have to check the last one. PC can be odd. PC, P into C. P is 7. P I can take 7. P is a prime number, 7 I can take. And into C composite number, I can take any number. 27 I will take, no problem. So if you multiply these two, how much you will get? 189. 7 7s are 49. 7 2s are 14. Yes, 189. And 189 is of course an odd number. Meaning the third statement is also correct. Therefore, you will have to go with the last option. All the three, 1, 2, 3, all the three are, of course, correct statements, right? So P plus C by P minus C, meaning prime plus composite divided by prime minus composite can be even. 2P plus C means twice the prime number plus a composite number can be odd. P into C can be odd. P and C, of course, it can be odd. If you multiply a prime number with the composite number, you can get an odd number, right? So all the three statements are correct statements. So 1, 2, 3 is the final answer, last option. Moving on to the next one. Here is our next problem. 125 identical cubes are arranged in the form of a cubical block. How many cubes are surrounded by other cubes from each side? Dear friends, it's cube. Cube is always a cube. What do you mean by that? Cube is always a cube. 3 cube. It is 3 cube. 3 into 3 into 3. It is like this. 27. So 3 steps. It is like this. 3 by 3 size. This is called cube. Right? This is called cube. This is of 3 by 3 by 3 size. Right? And if you say cover this by one more layer, then it will be surely become a cube of size 5 by 5 by 5. Okay. If there is a cube of size 5 by 5 by 5, if you take out one layer, outer layer, in the inside it will be a cube of size 3 cross 3 cross 3, right? So the meaning is the final answer will be surely 27, because inside it is covered by a layer, and if you take out that layer, inside you will get to see 3 cross 3 cross 3, this kind of cube, and using this cube you can obtain 27. And dear friends, when it is inside, it will be covered on all the 6 faces, right? And therefore the final answer is the very first option. 125 is 5 cross 5 cross 5. If you remove one layer, then it will be of this size, and all these cubes will be covered, surrounded by other cubes from each side. Of course, it is completely covered inside. So the final answer is 27. There is nothing much to talk about this. Moving on to the next one. Here is your next problem on the screen. There are 4 letters and 4 envelopes, and exactly one letter is to be put in exactly one envelope with the correct address. If the letters are randomly inserted into the envelope, so then consider the following statements. Statement number 1 says it is possible that exactly one letter goes into an incorrect envelope. Statement number 2 says there are only 6 ways in which only 2 letters can go into the correct envelopes. Okay, so we have got 2 statements here. Which are the statements given above is correct? Your options are 1 only, 2 only, both 1 and 2, neither 1 or 2. We have these 4 envelopes, and there are 4 letters A, B, C, D. 4 letters, 4 envelopes, right? it is possible that exactly one letter goes into an incorrect envelope. Highly impossible. If 3 are going in correct addressed envelopes, the remaining one, can it go wrong? Impossible. Assuming these are going to the correct addresses, these 3 letters. Can I expect this to go in an envelope which is addressed incorrectly? Impossible, because that is the only left out thing. The left out thing will be automatically correct. Therefore, straight away 1 is ruled out. 1 is ruled out. 1 is ruled out, meaning all these 3 are ruled out. Okay. So the answer is only 2. Now I will tell you how it is 2. There are only 6 ways in which only 2 letters can go into the correct envelopes. Now I will prove how second is correct. Okay. Now let me prove how second is correct, and therefore the answer will be in the end 2 only. Okay. These are the 4 envelopes, A, B, C, D, and we have got 4 letters. These two can go, these two letters can go in the envelopes which are addressed correctly, and these 2 are going incorrectly. Why? Because they are shuffled. This letter was supposed to go here, this letter was supposed to go there. Okay. So 2 letters are going in the correct envelopes, 2 letters are not going in the correct envelopes. This can happen, right? Possible. Possibility is there. These 2 are going to the correct envelopes and these are incorrect. And these 2 can go in the correct, these 2 incorrect, right? Now these 2 can go in the correct addresses, these 2 incorrect. These 2 can go correct, these 2 incorrect. What else? See, 1, 2, 3, 4, 5, 6. In all these 6, 2 letters are going in the correct addressed envelopes. 1, here these 2, all are different. Check it out, all are different. Okay, all are different. And these are the only 6 ways in which only 2 letters can go into the correct envelope. So everything is all right with the second one. So 2 only should be marked. Moving on to the next one. What is the remainder? This kind of question was also asked earlier, I think 2022 or 2021. See here, this is also on the expected lines. It is not a surprise question. Okay. You must have prepared for this kind of questions once you refer the previous year question papers, right? See here, it was on the expected lines 85. Before that, let me tell you one thing. 5 divided by 1. How much remainder you will get? Because he is talking about the remainder. What is the remainder when this is divided by 100? Okay. So if you divide by 1, what happens? 5 divided by 1. 1 5s are 5. 0 is the remainder. Okay, let me change. 7 divided by 1. 7 divided by 1. 1 7s are 7. 0 is the remainder. What is the meaning? The meaning, if you divide by 1, or by 1, if the number is 1 in the denominator, or if you divide any number by 1, the remainder will be always 0. This is clear. Now I will use this point. In the numerator, let it be any number. Divide by 1, always remainder is 0. Right? 5 by 1 is remainder 0. 7 by 1, remainder is 0. 110 10 divided by 1, remainder is 0. Let it be any bigger number in the numerator, divide by 1, remainder is always 0. Any number divide by 1 gives us the remainder 0. This is a point to be noted. Okay. Now 85, I will write this as 17 into 5. 17 5 is 85 into 87 into 89 into 91. 95 can be written like this, 19 into 5. 19 into 5. And then 96, I will write it like this. 2 into 2 into how much? 24? Yes. All this is there in the numerator divided by 100. Let me divide it by 100. 2 5s are 10. Then 5 2s are 10. There are 2 2s. There are 2 5s. So in the numerator you will have 10 into 10 and one big number. Divide by 100. 2 zeros, 2 zeros. In the numerator one big number, in the denominator we have 1. Any bigger number divided by 1 gives you the remainder 0. Therefore the very first option is correct answer. I will repeat. In 85 you will have 1 5. This is clear. In 95 you will have 1 5. That is also clear. In 96 we have got too many 2's. You can write any number of 2's here. Okay. So if you write say 8 12s are 96. These together and these together will get you 100. In the numerator 100, in the denominator 100, 100 will get out. Meaning you will be left out with only 1 in the denominator. Any bigger number divided by 1 gets you the remainder 0. Therefore first option should be marked. Okay. And if you want, I can give you one more method which is called remainder theorem and all, called by different names. And I think that is sufficient, but still let me give you one more method. See 85 and it is 100. We are dividing it by 100 and it is 85. How much will be the remainder? 15 is the difference. 15 is the difference, 85 and 100. How about this 87? 13 is the difference. How about 89? 11 is the difference. 91, 9 is the difference. 95, 5 is the difference. 96, 4 is the difference. 15, 13's 150 plus 45 is 195. 195. If you divide this by 100, 195, 100 2's are 200. But this is 195. Again you are left with 5 here. Then what else you can do? 11 9's are 99. 99, straight away you can take 1. 5 4's are 20. 20 you can take 80. 20 and 100, 80. 80 into 5, 400. If you divide 400 by 100, you will be left out with the remainder 0. 400 divided by 100, 100 4's are 400, 0 is the remainder. Again it is the first option. I think the earlier method was easier than this. Okay. Hardly we came across any calculations in the earlier method. Moving on to the next one. If ABC and DEF are both 3 distinct numbers such that A, B, C, D, E and F are distinct non-zero digits. They are different non-zero digits. Non-zero means other than 0, and distinct, all should be different. If you take 2, then again you cannot take 2 for any other variable, right? Non-zero digits such that ABC plus DEF is equal to 1, 1, 1, 1. Then what is the value of A, B, C, D, E and F? Dear friends, if you add 235 and 876, how much you will get? 5 plus 6 is 11, 7 plus 3, 10 plus 1, 11, 8 to 11. So ABC plus DEF is 1, 1, 1, 1, and all are distinct non-zero digits. A is 1 and we are not, A is 2 and we are not taken 2 for any other thing, right? So 235 plus 876 is 1, 1, 1, 1, 4 by 1, and this is how that problem was originally created. Okay, now the question mark is on, then what is the value of ABCDF? You just will have to add all these digits. 2 plus 3 plus 5 is 10. 8 plus 7 plus 6, this is 15 plus 6, 21. Together it is 31. It is very much there in the last option. That should be marked. Now your doubt may be from where we got these numbers. 235 and 876, that is purely by trial and error method, my dear friends, because see here we want 1. How can you get 1? 1 plus 0 is 1, but 0 is not allowed. Therefore you will have to go for other combinations, and I have been telling you he will be always concentrating on less than 10. Okay, so the numbers less than 10 he will always concentrate on that. So 5 and 6 together 11, 1 carry. 1 carry means we want only these together 10. How can we get 10 here? You cannot take 5 again because already we have taken 5. 5 plus 6 is 11, right? 1 is already carry, and we want 10 here together because this is 1 and we want 10 plus 1, 11, again 1, right? But can you take 5 plus 5? No, because already 5 is taken there. This is how you will have to go for trial and error methods, and you can do it. Okay, it is not like it is impossible to imagine, right? You can imagine. Go for trial and error methods and you will get it. This is everything about this. Moving on to the next one. D is a 3-digit number such that the ratio of the number to the sum of its digits is the least. What is the difference between the digit at the 100th place and the digit at the unit place of D? D is a 3-digit number. If you take 109, 3-digit number I took, and he has not said we must use a non-zero digit, right? You can take 109, and the ratio of the number, this is the number, and the sum of its digits, the sum of its digits is 10. The ratio is the least. That kind of numbers you will have to pick. That kind of numbers you will have to pick. So, and in the end what he is asking you, this is D, this is D, 3-digit number. We want the difference between the digit at the 100th place and the digit at the unit place. So we want the difference between these two. The difference between these two, if you take 0, okay, if you take 7, if you take 8, if you take 9, what happens? See here 1 and 9, okay, 1 and 9, the difference is 8. So the third option is correct. Now I will tell you how it is correct and how this is the final thing. 109 and 10. If you take 108, what happens? If you take 108, what happens? So if you take 108, 1 plus 0 plus 8 gives us 9. 9 ones are 9 12s are, right? So the ratio will be 12 here. Here the ratio will be how much? 10.9. So 12 is more than 10.9, meaning you are not allowed to take like this. Okay, meaning you will have greater ratio, right? So as this difference keeps on decreasing, the ratio keeps on increasing. And why we took 0 in between as one of the digits? If you take bigger numbers like this, say 2, 3, 7 and all, this will also become more, 12. Okay, then the ratio will be automatically too much. 237 divided by 12, see here, almost 12 2s are 24, almost it is 20, but here only 10.9 and this is the least, right? So it is better you take 0 as one of the digits at the center, so that you will have the least ratio, right? So the final answer is the third option, 8. Let's see the next problem, problem number 55. In an examination, the maximum marks for each of the 4 papers, namely PQ, R and S, are 100. In each paper we have got maximum marks 100 and there are 4 papers. Marks scored by the students are in integers. Marks scored by the students are in integers. A student can score 99% in n different ways. What is the value of n? In how many different ways he can score 99% of marks? 99%, 4 papers are there, P, Q, R, S. Maximum marks 100 each. Maximum marks 100 each. 99% of total marks. Total marks are 400. Meaning 396. He must have scored 396 marks out of a grand total of 400. Only then we can say that he has scored 99% of the marks, right? 99% of the marks he has scored. It only goes to say that he has lost exactly 4 marks. And in how many different ways he can lose those 4 marks? That is the meaning of this problem. In how many different ways he can lose those 4 marks. Okay, he can lose all the 4 marks in P paper, or he can lose all the 4 in Q, all the 4 in R, all the 4 in S. Okay, he might lose 1 mark in each of the papers. That is also one combination. Like this, in all, in how many different ways he can lose those 4 marks. That is the meaning of this problem. Now let us concentrate only on different number of ways of losing marks, 4 marks. 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. You cannot write 5, 0 because he has lost only 4 marks. Okay. See here, in the first 2 subjects, he has not lost any marks, assuming. Okay. Meaning all the 4 marks are lost in the last 2 subjects. Okay. He can lose all the 4 marks like this, 0, 4. I mean 0 marks he has lost in the third and 4 in the last, or he can lose like this, or he can lose 2 marks in the third and 1 mark in the last, or he can lose 3 marks in the third and it is not 1, it is 2, right? 4, 4, 4, 3 plus 1 is 4, and he can lose all the 4 marks in the third. So starting with 0, 0, how many you got? 5. 1, 2, 3, 4, 5. These are the 5 different combinations wherein he will not be losing any mark in the first 2 subjects. All the 4 are lost in either the third or the fourth or in both, right? These are 5. Now I will start with 0, 1. 0, 1. If you start with 0, 1, what happens? 1 mark is already lost. Now he will have to lose 3 more marks. And in how many different ways that can be done? In how many different ways he can lose the remaining 3 marks in the remaining 2 subjects? He can lose like this, right? 3 marks. 3 marks means like this. 3 marks like this. Sorry, it is 1. Or he can lose like this. 3 marks here. Okay. So how many you got here? 4 different combinations. I started with 0, 0. I started with 0, 1. Now I will start with 0, 2. Here it is 5. Here it is 4. Next it will be surely 3 and then 2, then 1. Now let's see how it is. Here you will surely get 3 different combinations for 0, 2. 0, 2, what is the meaning? First subject he has not lost even one mark. He has scored out of out. In the second subject he has lost 2 marks, meaning he has scored only 98 out of 100. Now the 2 more marks he will be losing in the last 2 subjects. How that can be done? In how many different ways he can lose the remaining 2 marks in the last 2 subjects, third and fourth. 2 marks. 2 marks means like this, 0, 2. Or it can be 1, 1. Or it can be 2, 0, right? So for this 0, 2 combination, these are the only 3. And for 0, 3 combination, you will have only 2. Now I will tell you how. 0, 3 meaning the first subject out of out. Second subject he has lost 3 marks. Now he will have to lose 1 more mark in together, third and fourth together. He can lose like this, 1 mark in the third and the fourth together. Or he can lose like this. These are the only 2 ways. So 0, 0, 5 combinations, 0, 1, 4 combinations, 0, 2, 3 combinations, 0, 3, 2 combinations. Now 0, 4. 0, 4, he has already lost all the 4 marks. He has nothing to lose in the third and the fourth. This is only 1. Okay, all these are different ways of losing 4 marks, starting with 0, 0. 0, 0 meaning assuming he has not lost even 1 mark in the first. Okay, in the first subject. First subject he has not lost even 1 mark. In this way, it will be 5 plus 4 plus 3 plus 2 plus 1. 5, 9, 10, 12, 15. Here you will have 15. Same way, you will have, starting with 1, 0, it will be 4, 3, 2, 1. That will be how much? 4, 7, 10. 10 here. Starting with 2, 0, it will be 3, 2, 1. 3, 2, 1. It will be 6. And here it will be 2, 1. 2 plus 1. That will be 3. And 4, 0, it will be only 1. So 15, 25, 25 plus 10. 35 is the final answer. The last option should be marked. Now I will give you how it is 3 to 1 in case of 20. Okay, you do the rest. Okay, now I will be doing only this 20 how it is only 6, and I can do even 40 also how it is only 1. Okay, we want him to lose exactly 4 marks and there are 4 subjects. Okay, now I will be doing this P, Q, R, S. These are the 4 subjects. 20 are fixed. What is the meaning of 20? In the first subject he has lost 2 marks. Second subject he has not lost even 1 mark. Already he has lost 2 marks in the first 2 subjects together. The remaining 2 marks he must lose in the third and fourth. These together 2 marks. It can be like this 0, 2, or it can be like this 1, 1, or it can be like this. Starting with 20, it is 3, 2, 1. So of course we have written 3 here, and these are the only 3 possible ways of losing 4 marks starting with 2. Meaning he has lost 2 marks in the very first subject. The remaining 2 he will have to score, he will have to lose in the third and fourth. Okay, now if you take 2 and 1, 2 marks he lost in the first and 1 mark in the second, meaning he has already lost 3 marks. Now he will have to lose 1 more mark. 1 more mark he can lose in this, or he can lose in this. Okay, so these are the only 2 ways. And starting with 2, 2, no other options. Why? Because already he has lost 2 marks each in the first 2 subjects, meaning 3, 2, 1. 3, 2, 1 we got 6. Same way you do for the others 1, 0 and 3, 0. Now I will be doing 4, 0. 4, 0, 1, that is very simple. He has already lost 4 marks in the first subject, 0 in the second. This we are starting with this part, so naturally he doesn't have to lose any mark in the third and fourth subject. So this is the only way out, starting with 4, 0. Okay, so 15, 10, 6, 3, 1, all these together gives you 35, which is there in the last option. Okay, and one more important thing here, to explain you we are taking too much of time. Once you understand this, you can do it quickly, and you don't have to write every time these numbers also. Okay, see here, first it is 15, then 5 less, 4 less, 3 less, 2 less. Okay, so there is an order, and you will have to catch that order in order to solve this problem. Okay, this is everything about this problem. Moving on to the next one. See, there are 5 persons, P, Q, R, S and T. Each one, 5 persons are there, P, Q, R, S, T, each one of whom has to be assigned 1 task. Each and every person has to be assigned 1 task. Neither P nor Q can be assigned task 1. Task 2 must be assigned to either R or S. In how many ways can the assignment be done? Same type as I have seen it, I think in the year 2018 or 19 CSAT. Okay, 100% same type. Okay, so this is also not a surprise question, provided you had peep into previous year question papers before attending the exam. Okay, so this is also on the expected line. We have got PQRST, PQRST, and we have got how many tasks? Obviously 5 tasks, because each and everybody should do only 1 task. There are 5 persons, each one of whom has to be assigned one task. Neither P nor Q can be assigned task 1. Task 2 must be assigned to either R or S. In how many ways can the assignment be done? Your options are 6, 12, 18 and 24. I will be writing tasks here. 1, 2, 3, 4, 5. These are the 5 tasks, right? Neither P nor Q, that is over. Now see here, R or S. Okay, task 2 must be assigned to either R or S. Task 2, he is talking about this task, second task, it should be assigned to R, or it should be assigned to, say, yes. Should be assigned to R, or it should be assigned to yes. Okay. Keep the remaining as they are. Now, R is blocked here. Again, he cannot do any other task because one person should do only one task. So, R is over. P or Q are not allowed here. P and Q are not allowed. Then who all can come here? These are the only 2 ways out. S and T. S should handle the first task, or T should handle the first task. This task can be handled in how many different ways? In 2 different ways. Okay. Either S can come here or T can come here. So the first task can be handled in only 2 different ways. But either of these 2, one will get engaged with this task. Now 2 tasks are also over and 2 persons are also engaged with them. Now forget 2 persons and forget the first 2 tasks. Now you are left out with 3 persons. Who are they? P, Q and one of these 2. 3 are remaining, and for them there are 3 tasks which are remaining. And out of these 3, any of the 3 can handle this task. In this task can be handled in 3 different ways. And after that 2, and after that 1. Okay. So 2 into 3 into 2 into 1. 2 3s are 6, 2s are 12, 1s are 12. What is the meaning of the whole story? This is about the first case. Second task is handled by R. If second task is handled by R, then in 12 different ways they can do the task. Okay. Or means plus. Or means plus. Or means again a fresh case. Again all are open to all the tasks. Okay. Now this is different case. Now here S is handling the second task. Now forget S, forget second task. Okay. Now let us concentrate on the first task. You will have to do those things first which have got restrictions. Yes, second task there is a restriction, we have done with that. Now the next restriction goes to the first task. Here P, Q not allowed. We have all these persons P, Q, R, S, T. Yes, forget him. P and Q cannot come here. Then who all can come here? R can handle the first task or T can handle the first task. This task can be handled in 2 different ways, and means in 2. And after one of them handles this task, you are now left out with 3 persons and you are left out with 3 different tasks. Now all the restrictions are over. Anybody can handle those 3 remaining tasks. And we have P, Q and either of these one. Okay. We have got 3 persons out of these 3. Anybody can handle this. And after that, any of the remaining 2 can handle this. And after that, and means into, and after that, remaining 1 must handle the 5th task. So 2 into 3 into 2 into 1 gives us 12. 12 plus 12, the final answer 24. So it is very much there in the last option, that should be marked. So this is everything about this problem. and it was on the expected lines. It is not a surprise, okay, problem in this question paper. Moving on to the next one. Here is our next problem. I think it is the last 80th problem. There are 3 traffic signals. Each signal changes color from green to red. Dear friends, this is also not a new problem. And if you come across signals, traffic signals, straight away think of what? LCM. Okay. So this is a problem based on the applications of LCM. Now let's see how this can be done. There are 3 traffic signals. Each signal changes color from green to red and then from red to green. The first signal takes 25 seconds. The first signal is taking 25 seconds. The second signal takes 39 seconds. And the third signal takes 60 seconds. And these are the only 3 signals to change the color from green to red, and the durations for green and red colors are same. At 2 p.m. they together turn green. At what time will they change to green next? Simultaneously. Go for LCM by taking all the available numbers in the problem. 25 seconds, 39 seconds, 60 seconds, all are in seconds, and our LCM will also be in seconds. See here, these 2 are divisible by 3. Always you must start with the least prime natural number. That is the most important rule connected with the calculation of LCM. 2 is the least prime natural number, but if you start with 2, this is the only number which is divisible by 2. Okay. It must divide at least 2. More than one number should be divisible by the same particular number. Only then you can start with that. So if you start with 2, this is the only number which is divisible by 2. Therefore, you will allow to switch over to the next prime, which is 3. If you start with 3, both these numbers are divisible by 3. So you can do that. It is not divisible by 3, so keep it as it is. 3 1s are, 3 3s are, 3 2s are. Now, if you start with 2, 3, forget them. Straight away go to 5, because 5 can divide both these numbers. 5 5s are, 5 4s are, 13 as it is. 5 3s are 15, 4s are 90. 95s are 450 into 13, right? 3 5s are 15, 15 4s are 60, 65s are 300 into 13, right? 13 3s are 900, all are in seconds. Your LCM will also be in seconds. So these many seconds you will have to wait, right? And we all know 60 seconds means 1 minute. These many seconds means how many minutes? Just divide this by 60 to get it in minutes. Okay, this will give you in minutes. 0 0 will get out, 6 1s are, 6 6 are 36, 3 36 5s are. What is the meaning? 65 minutes. After 65 minutes, they will change. Not just after 65 minutes, after every 65 minutes, they will change. After every 65 minutes, first time after 65 minutes, next time after 130 minutes. What do you mean by 130 minutes? 130 minutes meaning 2 hours 10 minutes. Do you agree with me? 2 hours 10 minutes is the meaning of 130 minutes. For 120 it is 2 hours and then 10 minutes. So 2 hours 10 minutes. After 2 hours 10 minutes again they are going to change. Right now the time is 2 o'clock. After 2 hours it is 4 o'clock and then 10 minutes. It is 4:10 p.m. They are going to change. So the final answer is 4:10 p.m. Okay, and we have seen many problems of this kind in the past. It is not a new problem. Traffic signals, okay, not only traffic signals, even the bells. There are 4 bells. They're toll at the intervals of 2 seconds, 3 seconds, 4 seconds and 5 seconds respectively. In 1 hour of time, how many times do they toll together? This is also a problem from CSAT, and it is also on the same lines. Not only that, there are 4 persons who are firing bullets, okay, at different intervals. How many times do they fire together in a particular period of time? These kind of questions have been asked. It is not a new problem, friends. It looks like all are tough, right? But I think you can pick 27, undoubtedly, the easier ones. With these words, let me close this video. Thank you one and all. I wish you all the very best for the next time. Thank you one and all.